how is space helping us with biotech, semiconductors, mining, private orbital stations, that sort of thing? Do you want to sort of pick one and let's start going down a bit of a rabbit hole?
Yeah, sounds good. You mentioned biotech is the first one. Let's start with that. So we did complete some of the understanding of what's happening in the industry, and in the last 20 years or so, more than I think around 2,000 experiments have been conducted on ISS. That was mainly research, research experiments. Talking about stem cells, production of cancer treatment, vaccines, even IVF, embryos, so many different things. But these experiments have been just pure research because it was super expensive, difficult to book, no opportunities to scale. Because now it's all changing, because easier to launch, now building kind of real estate in space, private stations. Elon Musk is building Starship, and some people say we don't even need private station. We can just, keep the Starship flying around the Earth. That's already one Starship is already bigger than whole ISS, right? So that what gives us the space for build some lab or small manufacturing facility in space. Plus, also, how do you bring it back? Now we do have capsules. And one of the companies which I closely following, which called Varda, which probably now one of the market leader in terms of the kind of in-space manufacturing. It's already big. It's I think they just closed Series B. So they just done 2 return capsules back to Earth as well. So it's kind of a routine process now. Launch something, then manufacture something, bring it back to Earth. That's kind of in a nutshell. That's what people would like to do, right? And hopefully at some point it will become as a not even remarkable anymore to even talk about it, right? So example of so I already mentioned about one of my portfolio companies that doing crystallization of protein in space. And the reason why it is much better in space is because the molecules of protein, they're very geometrically complex. So if you grow them big, they collapse, and you can only grow them to some certain size. That means but in zero gravity, in microgravity, they can grow bigger. So there is no gravity which collapsing them, and they grow more symmetrical, more pure, and bigger. For cancer patient, that means that they can switch from a drip to an injection. And imagine if you have a cancer that you don't have to go and every day to a hospital and have a nurse putting needle into your vein, but you can actually inject yourself at home. And that's a huge lifestyle change. It's also a huge potential, because it's a new patent, right? For example, that's for pharma company that can also hit a huge new revenue stream for. So it's good for everyone, right? And the reason why it is possible today, let's say approximately 1 kilo of this protein costs 100K. We don't know exact number yet, but I think that's what number kind of I've heard approximately. So if you want to launch something to space which costs, let's say, 2K, again approximately, build something there, the robots will create you these proteins, and you send this box back home, which will be also probably a couple of thousand. The numbers are not public yet. That you still have the margin, right? That's a real business. It's not a research experiment anymore. So another company I invested in the UK as well, it's as an angel investor. It's called Space Forge. That they do similar thing, but they do it for semiconductors. So the semiconductors, the compound crystals which you can grow in space, again, because of the zero gravity, because of the deep vacuum, because of the special conditions, you can't reproduce on Earth. Deep vacuum is super difficult to do. Microgravity, you can't reproduce because we can't. It's physics, right? We can't break it. So the compound crystals for semiconductors, they grow 10 times longer in space and 3 to 5 times more pure than on Earth. That means that if you produce semiconductors from them and use them on Earth, they will consume 50% less electricity than they need. And that's, imagine, like, for us, we already have so many, like, we already have energy crisis, we already have, people complaining about all data centers, taking all the energy, we don't have enough supply, we have like emissions, blah, blah, blah. That can potentially, offset some of these issues already. So that's kind of just a couple of examples of what can be done. But I've seen companies, because I have like lots of decks, from different startups. But basically people, so these ISS experiments, which I mentioned to you, these are public data. Anyone can go on the website, look at this, what has been done, the results. And a lot of people now, like a new generation of entrepreneurs come in, right? And say, oh, let me look at this. Okay, this one, okay, organoids hasn't been done yet. Okay, I'm going to call the scientist. I'm going to create a pitch deck, find money, apply for grant, done. This is a startup going, right? So previously, I think previous generation of entrepreneurs have been mainly like engineers and scientists, but now we see lots of people coming, like from outside of these areas and just kind of a bit more, general view. Okay, let me find a co-founder who's a scientist, and I'm just going to do a startup based on that, which is great. Which is like, that's exactly what happened in I think the internet in 1990s. The first wave was, again, engineers, software coders, and now people, oh, actually, that's how we can make money here. And a lot of not normal, but generalist founders came to the play, right? So I think that's what's happening now. I mean, that's my hope. That's what be happening more and more in space industry as well.
Alex, can I ask you, because this is something, because this is so, I'm learning so much about this. I came into this conversation with the view that something like biotech, like space, would be the worst place for it because of things like, my understanding of astronauts going up there and their muscles, atrophy, and they have to exercise all the time. But even if they exercise, when they come back to Earth, it's just so much worse or harder. So this notion that there's aspects of space that do things even better than on Earth, it still feels kind of shocking and almost like hard to believe. Like maybe another example is, down here on Earth, we experiment a lot with animals and with mice, but then it works on the mouse, but then you try to transfer it to the human, and oh well, like it doesn't translate. So are you saying what I think you're saying, that there is like this almost way in which the counterintuitive truth is the truth?
So, I mean, some of the COVID vaccines have been formulated on ISS, right? So, like, I was reading some of the articles about that. It's actually fascinating, right? That you can almost say that space helped us to beat COVID, right? I do think that there's a difference between people actually being in space and on the moon, because we have a lot of issues with radiation protection, and generally I don't think the space can make you younger, right, or more healthier if you go there often, right, if you stay long. At least we don't have enough data to prove, like, that's that kind of, the real, because how many people have been to the moon? Only 12, right? It's not significant number to actually to kind of make any conclusions. But in terms of producing something in space to make you healthier, younger, or kind of some anti-aging treatments, that's definitely a big thing. A lot of people look at it, a lot of people do it, lots of research has been conducted. So I started seeing people doing organoids, stem cells, cancer treatment for sure. And some of the things we don't even know what's happening, because lots of big pharma companies now booking the flights with these companies, doing experiments, filing the patents, which we don't know. But I think what I've heard, like Varda is fully booked for next couple of years by pharma companies, right? So that means that there's definitely kind of all of this research is now trying to be commercialized and actually in real products. Yeah, it's different, right? Like, one thing is you use something which was produced in space. Another thing, you go to space. I don't think you're going to have like anti-aging treatment hotel in orbit. Definitely, probably not in the current decade, for example, but maybe later. Yeah, but it's still harsh to go there. But doesn't mean we can use the products out of there.
Christoph doesn't need those. He's young and handsome looking as he is. You're already a space monkey. I mean, I guess you talked about biotech and semiconductors. I guess there are, like in my mind, you see, say, like in TSMC, like their manufacturing facility, and the people who are building semiconductors on Earth, like they're wearing almost like spacesuits in these environments because they have to be like ultra clean. And I guess that's a huge advantage of being in space, right? You've got like hard vacuum, probably don't get a much cleaner environment. But then, as you say, challenges around radiation, thermal dissipation. Like we think about space as being really cold, but actually, I guess because there's a vacuum, my layman's understanding actually it's quite hard to get rid of heat, and heat is a big problem when you're in like operating some of these manufacturing processes.
Like it's one of the biggest debates. It's like if you follow, for example, I do follow Y Combinator every cohort very closely, and you start seeing that a lot of companies actually, lots of space companies now maybe 2-3 companies every cohort you see there. And one of the companies was Lumen Orbit, which they started doing edge computing in space, and like they now pivot to data centers in space. And data center space is such a good pitch, right? I mean, if you like think about like very high level, you have solar energy there. You don't need to come up with a separate. And there's no clouds. There's no day and night. You can just constant, solar energy supply. It's cold. You don't need to cool it, and you have all the satellites there, so you can connect directly to the internet again very fast. And there's no FBI can come, so it's a physical security as well, right? So there's no Chinese can put the plug or FBI can knock the door and say, "Hey, we arrest your data center." It's security and safety as well. Plus, you don't need to worry about how they go, which. Data privacy rule we have to use, right? Because it's like all up there, right? So it's much easier. I mean, that's kind of easy sell, but then you exactly would start thinking about what you just mentioned. Okay, how long actually we can, sustain a supercomputer in space with all radiation? The architecture of computer has to be different. So much layers of protection. We can't control, the redundancy procedures has to be different. The heat exchange as well, exactly. Easy to say, oh, it's cold there. we don't need, but like what's happening today is, it's getting cool because of water, liquid, or because of the air, right? And how do you replicate exactly the same in space? I mean, I would like to see what are the engineering solutions they come up with. But I think I've seen already maybe 5 or 7 different startups pitching me data centers in space, and I would like to see how, like, what would be the, even Amazon, I think they had some projects about that, like AWS. So, and if you look at I'm not sure if it's a speculation or not, but Eric Schmidt recently became an investor and CEO of Relativity, right? And one of the things he mentioned is because it's like because he wants to build data centers in space, all kind of launch data centers. And kind of, if you think about, okay, data centers, we need more data centers, we need more powerful for AI, for LLMs, but we keep building them here. It's kind of keep causing lots of issues for our environment. Why don't you move it to the orbit, right? It's kind of logical, but I still would like to see how it will, present itself. Hopefully, we'll see it in the next couple of years. That's actually one of the big things everyone is waiting for.